All right, so we're talking about trigonometry. Where does that come from? We're going to abbreviate it as trig. Yeah, it talks about triangles. It talks about maybe the study of triangles. Now, trig talks about basically these three major, we'll call them functions of a triangle, right? Now, that comes from, if you were to take a circle on a coordinate graph, okay, and then let's say in one case, make the hypotenuse of a triangle also the radius of the circle. So take a look at that piece. Here I've made a right triangle in a circle on a coordinate graph. Okay, on a coordinate graph, in which this piece here, we could say is the radius, and we could also say it's the hypotenuse. Right? This is where this whole sine, cosine, tangent comes from. Looking at this piece of information, and then being that, given that radius, hypotenuse, kind of coming up with a ratio of these two sides. Now, if you look at a right triangle, how many degrees do you know you have? You know you have 90 degrees. In a triangle, 180. So you know that the remainder of these angles, these two angles here, have to be what? What type of angle? How could you classify an angle? Acute angles. And what we could say trig is, we could say is a ratio of the sides, or of sides, I don't know how you could grammatically write this, we'll just say it's a ratio of the sides of an, what kind? Of an acute angle, yeah. When we're dealing with trig, we're always going to be referencing, you have theta, I believe this is the delta sign, but you're going to be always referring to these two acute angles to identify sides and angles. So let's take a look at that, okay? Let's take a look at a right triangle in reference to a certain acute angle we're looking at. Let's say we're looking at this angle here, call it angle A, call it theta. Now, if you're looking at this acute angle, it's going to have three main pieces. One of which being the side opposite the right angle, which we know is the hypotenuse. I like saying it like that. The other being the side that is non-adjacent, so it's not touching the angle A, which we're talking about. It's not adjacent, and it is opposite. It is opposite. You also have an angle here, or a side here. Let's use a different color. What do we have? We have a pink here. Side here, which is connected to this angle, but not the hypotenuse, and we're going to call that adjacent. So you have the hypotenuse, which is opposite right. You have the adjacent, which is connected. Here's a symbol for angle to angle. And you have the side that's not connected to the angle. Right? And that's how you know your three pieces here. Basically, your three pieces being opposite, adjacent, and hypotenuse. And we're going to use, let's say I'm looking at an angle. Let's look at it from this perspective now. Maybe I'm looking at angle B here. Here you would have an opposite, a hypotenuse, and adjacent. And that's how we're going to be looking and labeling our sides and angles with these capital letters here. All right? So now let's start looking at how can we use these trig functions to set up a ratio based on my acute angle in order to find maybe a missing side or angle. Now, one of these key pieces, and right away I don't want to talk about it just yet. Actually, let's take a look at sine. And let's look at the same angle we're working with here, angle A, call this B, call this C. Okay? Let's say I have a Pythagorean triple, 3, 4, 5. Right? This I can get from using my Pythagorean theorem, 3 squared plus 4 squared is equal to 5 squared. That's true. So here's my 3, 4, 5. And let's say I'm talking about trig functions according to A. Let's say I'm talking about sine of A is what ratio? Sine of, or cosine of B, or A, I'm sorry, will be what ratio? And tan of A will be what ratio? Now, your sine is going to be a ratio of your opposite over hypotenuse. Your cosine is going to be a ratio of your adjacent over hypotenuse. And your tangent is going to be a ratio of opposite over adjacent. Now, what I would do when working with these ratios is I would first look at the angle that they're giving me. Okay, I'm working in this angle here. And I would identify my sides as opposite, hypotenuse, and adjacent. And in doing that, I'm actually able to just very quickly set up opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, which would be 3 over 4. And that's all we're really looking for. When I ask what is sine of A, all you're giving me is the opposite and the hypotenuse. That's all we're doing. You're giving me this ratio based on this acute angle. Now, if you start looking at this triangle from, like we did here, a different perspective, and you're looking at it from angle B, which now makes this your opposite, this your adjacent, and this your hypotenuse. And just like this, we had 3, 4, 5. Things become just a little bit different, where in this case, my sine of, I'm working with a different angle now. I'm working with B. My sine of B is actually now going to be 4 over 5. So basically, these two are switching, because now the 4 became my opposite, where originally it was my adjacent. And if I'm looking at cosine of B, I'm looking at 3 over 5. And I'm looking at tangent of B, I'm working with 4 over 3? 4 over 3, which is the flip version of this. Okay? Now again, your O, your N, yes. That's okay. It'll still work, but thank you. Here you have, always kind of notice what changed. This is your reference point. This is how you're establishing. I like to establish my opposite side first, then maybe hypotenuse, but whatever works for you. This is how you're setting up your ratios, okay? Now, if you're comfortable setting up your ratios, then okay, we can start using trig, and you're gonna have to have some sort of calculator that has the sine, cosine, tangent functions on it, but we can start working with certain triangles that, let's say, have certain letters and certain sides. So let's say we're looking at this triangle here. Who could tell me what pieces of that triangle that they're giving us?
The hypotenuse and the it's not the adjacent. It's 90 degrees.
And what is this?
It's the adjacent.
Well, opposite.
It doesn't give us the adjacent. It's the opposite?
Well, okay, now, depending on which angle.
Depending on which angle it is.
Well, I'd have to give you an angle, right?
Yeah.
So that's important. So now let's say that's an important piece. We have to look. Let's say I gave you this as your angle. I gave you 22 degrees. Now,
They gave you the opposite.
they gave me the opposite. And what do we know is associated with opposite and hypotenuse?
So you said what?
Sin, we're going to say sine. We're going to say sine. So I know sine is matched up with O and H, right? So if I'm trying to solve for an x or a missing side, and I have an opposite hypotenuse, well then let me just set up sine of what's my acute angle? 22 is equal to my opposite, x over 18. Now, algebra principles here, I'm just multiplying both sides by 18, and then I go to my calculator, 18 times, use your, and I'm going to need someone in the background to help me with some of these calculations.
Can I do it?
Yeah, what is it? What do you got?
6.74.
6.74. Can I ask you, Benny, because we've gone over this, what it is that you need to do in order to make sure that's a correct number? Maybe more so how your calculator is set up.
Oh, you have to change it to degree.
You have to change it to degrees. So you have a mode button on your TI whatever calculator, and you'll see radian degree. Most calculators will start off set to radian. Make sure this is what is highlighted here. This is what you want before you go forward. If you put this in radian mode, you're not going to get a correct answer. So let's say we're looking at another triangle, okay? And let's say we're looking at ABC, and this time I'm giving you this as an angle, and maybe I'm giving you here, and maybe this side here. First thing we want to do is look at what are they giving us in respect to the acute angle. So what angle are they giving us? 47. And what do we have? What do we have with the 47? What else? What do they say again? They're giving us, very good. They're giving us the adjacent. So they're giving us the side that's connected to the C, adjacent, and they're giving us the hypotenuse. So what do you want to use for that? Cosine. So when I have adjacent and hypotenuse, I'm using cosine. Cosine of my acute angle is equal to my adjacent over my hypotenuse. Now, I will tell you that I can go through my algebra principles, multiply both sides by x. X times cosine 47 is equal to 10. Divide both sides by cosine 47. X is equal to 10 divided by cosine 47. But what did you guys notice from where we started? What did you guys notice from where we started? What happened? Here's where we started. Cosine 47 is equal to 10 over x. Now I have x is equal to 10 over cosine 47. What did you notice? Anybody notice happen there? Just something good.
The x and the cosine 47.
There was a switch here. This just, all this work, multiplied by x, divided by, can be just, if you're practiced enough and you see it enough, you notice that, oh, if my x is on the bottom and I'm solving for a side, then I could just quickly switch the two. You could just make a switch, and that'll work. And this is what you would put on your calculator, and your answer would be 14.66. And I'm going to use the approximation number there because I'm sure there's a lot more decimals involved, right? And this is solving for a missing side. So instead of multiplying by x, dividing, you just see the x on the bottom, and you make a switch. Now we've talked about so, we've talked about co, so probably it would be time to talk about to. And if I'm talking about tangent and I'm giving an angle here, let's say, let's go 62 degrees for this. Let's make it a little bit bigger of an angle. What sides, 1, 2, or 3, am I going to need in order to solve that using tan? 1 and 2. I'm going to need my adjacent and my opposite. So let's say in this case, we want to put our x on the bottom again to show that type of example. So I know tangent's opposite over adjacent. So I'm going to make my adjacent x, and I'm going to use the same, I'll just use 10 again. No problem. So I know that that's side 3. We don't know what this is. So let's say we're using tan of my acute angle, and we're saying that's equal to whatever my opposite is over my adjacent. But Hernan told us that we can just switch. So if we're solving for x, we're just going to switch. And we're going to do 10 divided by tan 62. And we're going to get 5.3. This could or could not be wrong. We can fact check that later. Yeah, we use tangent because they gave us an opposite over an adjacent.
So we
Here,
do 10 divided by whatever the tangent is?
tangent of the angle that they gave us, yeah. But originally it was set up tan 62 is equal to our opposite over adjacent. So we filled in our 10 for opposite, our x for adjacent. We noticed the x was on the bottom, so we made a switch. Alright, now I'm going to give you guys just a little, we'll keep that up, just a little insight. I don't want to go too far, but just kind of a little snapshot into solving for an angle. Now, one thing you have to know about before we get into this is how you can rewrite 1 over x. And a fundamental exponent rule is that 1 over x can be written up as x over 1. And if I did 5 times 1 over x, I can write it as 5 times x to the negative 1. Because these two things are the same. That's important to know going into our next little piece here, solving for an angle. So let's just look at one example of where we're solving for an angle, and they're giving us an opposite side, and they're giving us an hypotenuse. Since they're giving us opposite hypotenuse, OH, I know it's sine, so I know sine of x. In all the other ones, what do we have? We have the angle. Now,
We don't have
we're
to.
solving for the angle. Here we're solving for a side, here we're solving for an angle. Now, what you'll notice, okay, I have my opposite over hypotenuse, right, my OH. What you'll notice, if I want to get x by itself, let's say you had 3x is equal to 9, sine x, right? In order to get the x by itself, I divide by 3. So, okay, let me just divide by sine, and I should get my answer. And then you go over to your calculator, and you're like, oh, I got this, no problem. And sine, and then parentheses, You're like, well, there was an x there, let me put an x in there, and then next thing you know, it's going to say error. And you're like, now, this is why I showed you this here. What you can do, instead of dividing by sine, since you know 1 over x is equal to x to the negative 1, then basically when you divide something, you're multiplying by 1 over that number. So basically I'm dividing by 1 over sine. So what I'm going to do is, I'm going to make sine to the negative 1, which you would call inverse. Now there's a whole other separate lesson that we could go through to explain this kind of exponent thing, but it's like a fundamental rule you should understand here. And then basically what you end up doing is saying on your calculator, there's a second button, and then if you look at your sine button, above that, in blue, I don't have blue, you'll see sine negative 1. So if you're solving for an angle, what you need to do is multiply both sides by sine negative 1. That'll cancel this out. And then you'll see on your calculator sine of negative 1, and you're multiplying to 8 over 10, your opposite over hypotenuse, and then you would get something like 53.13. And that makes sense, because this is a 90-degree angle, and this would fit as a 53.13.
How did you get from there in the black to in the green?
Here,
Yeah.
I, instead of dividing by sine, I multiplied by sine negative 1. And in order to do that in a calculator, I have to hit my second button and then my sine button. So basically, in order to get x by itself, because basically what ends up happening is you get x is equal to sine negative 1 of 8 over 10. And this is what x was. This was our x. We were solving for the angle here. So you're plugging that in. Now, somebody asked me in another class, Duff, can you do sine of C? What if you do sine of C? What would that be? Can you do that, sine of C? Yes or no? Take a guess.
Yes.
Why not? Take a guess. Why wouldn't you be able to find the sine of C?
The opposite is like the hypotenuse.
Opposite of hypotenuse, so you're getting there. But what is trig?
Sine.
What is trig?
Sine.
It's the ratio of the sides of an acute angle. Can I do sine of C? Why not? This is a 90-degree angle. It is not an acute angle. So you can only use these ratios if you're working with your acute angles. You would never deal with any trig triangle or trig question in which you're finding the opposite and hypotenuse of a right angle, because your opposite is also, like Steph was telling us, is also our hypotenuse, and that's an underlying problem. And he's got a square root. He has maybe I'll just use small numbers here. He has a square root. He has this hypotenuse, and they're asking for sine of A, right? And so he sets it up opposite over hypotenuse, and he doesn't see his answer anywhere. The reason for that is that cannot leave a radical on the bottom, because that's known as an irrational number. Now remember from our 30, 60, 90, one way to get rid of that is to multiply this by its conjugate, which is just multiplying by 1, and you end up with 2 square root 29, and then 2 times 20. Now 29 times 29 is just, remember, just 29. Now if I'm going to solve this, 2 times 20, 40, 2 times 9, 18, so 58. So I would get 2 square root of 29 over 58. And you'd have to reduce here, where 2 goes in once, and 2 goes in, what is that, 29 times? Probably. Let's hope. So you would get, and I bet you your answer would look like square root of 29 over 29.
Wait, in the beginning you said 2 goes into what one time?
2 goes into 2 once.
Oh, okay.
2 goes into 58 29 times.
Okay.
This is if you end up with a radical on the bottom when you're doing your opposite over hypotenuse. You can't leave a radical in the answer and the denominator. So you multiply by 1.